Good afternoon, everyone. My name is Tim Song. I'm a developer programs engineer on the Android DevRel team at Google. And today, I'm going to talk about Jetpack and how to choose the right components for your app. So first, what is Jetpack? Jetpack is a suite of tools, libraries, and guidance to make high-quality Android development easier. It helps you accelerate development. Components are individually adoptable, but built to work together while taking advantage of Kotlin language features that make you more productive. It helps you eliminate boilerplate code, and your Jetpack manages tedious activities like background tasks, navigation, and lifecycle management so that you can focus on what makes your app great. And finally, it helps you build high-quality, robust apps. Built around modern design practices, Android Jetpack components enable fewer crashes and less memory leaked with backwards compatibility baked in. It is also our recommended way of building apps. Now, Jetpack is divided up into 4 categories: foundation, architecture, behavior, and UI components. And let's dive into those a little bit more. The foundation components provide cross-cutting functionality like backwards compatibility, testing, and Kotlin language support. Now, I've seen many slides today actually use Kotlin for their code snippets, so maybe a quick show of hands. How many here are currently using Kotlin in their Android apps? Well, that's a lot of people. It's almost everybody. That's really good to see. Next, we have the architecture components that help you design robust, testable apps. We have behavior components that help your app integrate with standard Android services like notifications, permissions, and sharing. Finally, we have the UI components that provides widgets and helpers to make your app not only easy, but delightful to use. So that's a very, very quick overview of Jetpack. Now let's see how we can actually use that in our app. And for that, we'll talk briefly about Android X, what it is and why we need it. Android X is the package name and open source vehicle for Jetpack libraries. It fully replaces the support library, and just like the support library, Android X ships separately from the Android operating system and provides backwards compatibility across Android releases. So the Android X library is released on roughly a monthly cadence with some of the components that are in alpha status that ship more frequently. Now this is in contrast to the operating system, which ships every year or so. Now, why do you need to use Android X? Well, new Jetpack development only happens on Android X. So I'm sure many of you are working on an app that might still be using the old support library, so migrating the Jetpack is something that you'll have to do. And for that, we provide a tool that's available in Android Studio. This tool will map the old support libraries to the new Android X packages, and you just need to run it once for your project. It works across all of your modules. Now, if you don't use Android Studio or prefer to script your migration, we have CSV files available on our website, developer.android.com, that provides these mappings. Now that we've covered Jetpack and Android X, let's look at an app that actually uses Jetpack components and how they work together, and then we'll look at some code. We'll also talk about what problems each of these Jetpack components will try to solve. So this is Android Sunflower, which is a sample gardening app that illustrates Android development with Jetpack. We'll do a quick walkthrough of what the app looks like, and then we'll look at some code. So when the user first loads the app, they're taken to their My Garden page, which is initially empty. We have a call to action where the user can tap on the button to go look at the list of plants that they can add to their garden. Now this is a list of a dozen or so plants that ships with the sample. From there, they can tap into a specific plant to learn more about it, such as its name, description, its watering needs, basically how often the plant needs to be watered, and it has a floating action button that the user can tap that will add the plant to their garden. Now, after adding a few more plants, their garden will look something like this. We have a list of cards where each plant shows when it was first added to the garden, when it was last watered, and when it next needs to be watered. Now this is similar to many other apps out there, such as a shopping app or a reading or TV watching app where you have maybe a list of products that you'd like to purchase, kind of like the plant list, and then your checkout or your shopping cart, which is represented by My Garden. Now, Sunflower also shares some common technical challenges with other Android apps, such as data storage, navigating between destinations, and updating the UI to respond to changes in your data. Now, this is a design of Sunflower. It's written entirely in Kotlin. It leverages Kotlin features such as extension functions and coroutines. It has a model view model architecture, and it follows the navigation guidelines of having a single activity with many fragments. And it's also an open source sample app that is developed entirely out in the open on GitHub. Now, going back to the list of Jetpack components, here are the ones highlighted in blue that Sunflower currently uses. We'll focus on a subset of these for the rest of the talk, namely Room, Live Data, View Model, Data Binding, and Navigation. Now, let's take a look at some code. So a gardening app needs to know what a plant is, and thankfully, we have the Kotlin data class to very easily represent that data. We have like the plant ID, its name description, and a watering interval with a default of 7 days. Now, there are many ways to sort data in an Android app. You have memory, shared preferences, to disk, but for our needs, we need some kind of structure around the data, so we'll use a database. Android has the built-in SQLite database, but we want to use the Room Jetpack component for that. The Room provides an abstraction layer over SQLite for more robust database access. So here's how we can turn our data class into something that Room we can use. We add a few annotations, and I'll start at the top. We add an entity annotation, meaning like where this data will be stored in the database in the plants table. We also specify its primary key of plant ID, and also have a column info of ID. Now, you'll notice that some of the other variables don't actually have variables associated with it. Room is actually able to infer, based on the variable name, what that column name should be. Now that we have our database table defined, let's explore how to fetch, insert, and delete data from the database using DAOs, data access objects. On top, we have 2 queries. We have a query to get the entire list of plants or a specific plant. You'll notice that there's some query annotations with that. And in the second one, where you get a specific plant, we actually pass a plant ID as a parameter to the function, which is then passed over to the query to fetch a specific plant. Now in here, there's also an insert function, but you'll notice that there's no SQL associated with that. Well, with the insert annotation, Room knows that whether you're passing in a list or a plant, it knows to insert your data correctly into your table. And if you have a conflict, there are several ways to resolve it. In our case, we actually want to replace the data. Now you might notice that with getPlants and getPlant, the list and the plant object are wrapped in live datas. Well, this is a way to observe on data that may be changing, and we'll cover that in just a little bit. Finally, to round out your Room implementation, you'll need to subclass a Room database. In here, you have an annotation of the actual database and the entities that it should be aware of, in our case, the plant class. And in here, we have a list of our DAOs, such as our plant DAO. From there, we move a little bit higher on the stack to our repository. Now, repository is the gateway between our data layer and our view model. In our case, we're using the database as our data layer, but it can easily also be the network or the file system. And in here, this is a single source of truth for our plant data, and so this can be used by different view models. For example, the plant list view model will use the getPlants method to get an entire list of plants, or the plant detail view model will just get a specific plant. And so we'll move on to the plant detail view model. The view model is another Jetpack component and provides the bridge between business logic and the UI. It's designed to store and manage UI-related data that is lifecycle aware. So what that means is that, let's say you rotate your phone, your activity and fragments are destroyed and recreated. So if you want to preserve your text views in your edit text, a view model can help you do that. Now in here, we have a couple of live datas. We have isPlanted. Basically, this tells the floating action button whether or not to be shown, and the plant data itself, which is something that we get from the repository. Now, Live data is also a Jetpack component, and it is an observable data holder class that is lifecycle aware. It respects the lifecycle of other app components such as activities, fragments, and services, and only updates components that are in the active lifecycle. So now let's see how the view model is being used in the fragment. So in here, we get the PlantDetailViewModel, and we'll use the data binding to surface that to the UI. Now, data binding lets you bind the layout UI to data sources using a declarative format rather than programmatically. So let's take a look at how that works. And for that, we'll go back to the plant detail page, and we'll focus on the plant title and the floating action button. We'll go to our layout file. In order to use data binding, we'll need to make sure that the root element is the layout element. And in here, we can define variables. We want to define a view model variable, which we will then set in the fragment, and then this can be used later on in the layout file itself. So this is going back to the plant detail fragment. We'll use the data binding util to inflate our plant detail layout. From there, because we want to use live data with data binding, we'll need to set a lifecycle owner. In this case, it's the fragment itself. And finally, we set the view model variable to our plant detail view model. And now going back to our layout file, you'll notice in our text view, we can specify the text directly using the plant from the view model and get its name. Now, this provides some advantages, as in you don't need to use find view by ID in your fragment and then adding a set text on top of that. Now, to kind of see live data work, we use also this data binding in our floating action button. So isPlanted will change after the user taps the button. So it'll change from false to true, and then this knows whether or not to hide the floating action button. Now, this saves a lot of logic within your fragment of having to observe on that directly and then manually changing the visibility of that floating action button. So this is kind of covers the end-to-end of the data, getting it all the way from the database and servicing it to the UI. Now let's talk about how we want to navigate through our app. And for that, we will use the ViewPager 2 and the navigation Jetpack components. Now ViewPager 1 is also a Jetpack component, but ViewPager 2 provides some advantages such as right-to-left support and vertical orientation scrolling support. Now for our ViewPager, we have a few fragments, the My Garden and the Plant Detail fragment, and these are side by side. There's no like hierarchy between them. But if you want to navigate to the plant detail page, well, suddenly we need to worry about fragments being in our backstack, and that's where the navigation component comes in. The navigation component provides a consistent API when navigating between destinations, whether they're activities, fragments, or other components. It also provides a safe args plugin, which is a preferred way to pass data and ensures type safety, and we'll look at that in just a little bit. Now, for navigation to work, we'll need to define a navigation graph. Now, this is an XML file. In here, we define our ViewPager fragment. You'll also notice that it's also listed as the start destination. So this is the fragment that's shown when your app is first launched. In here, we have an action with an ID and a destination being the plant detail fragment. Now, this lets the navigation controller know that you want to allow a navigation from one fragment to another. If you don't put this action in here and you try to navigate from the ViewPager fragment to the plant detail fragment, navigation controller won't let you do that. Continuing on in the navigation graph, we have the plant detail fragment. Now in here we have an argument of plant ID. Now this is a way to tell navigation control that if you're navigating to the plant ID, you need to also provide a plant ID which the fragment will then expect. And we'll talk about that in the adapter in a couple of slides. So how do you use a navigation graph? Now this is a layout file for the main activity of the app, and in here is a fragment block. You pass that particular navigation file to the nav graph, and so it'll be able to use that for your view controller. If you have many activities, you can have a different navigation graph per activities. Now going to the plant adapter, which backs the recycler view for the plant list. In here, we have a click listener that when a user taps on a particular plant, we want to obtain the direction of where the user wants to go. In our case, from the view pager to the plant detail fragment. And you'll notice that we passed a plant ID there. And finally, we find the nav controller, and then we navigate to that particular direction. If you don't put in the plant ID, you'll actually have a compile time error. So this is another way to kind of guarantee that your data is there where it needs to be. Now this is a simpler way of using intents and then getting the nav directions to set particular IDs that you need to pass, and then use a navigation controller to navigate there. So on our plant detail fragment, in our onCreate view, we actually get the plant ID from the list of arguments, which we then pass to our view model, which then passes it to our repository and then down to the database to fetch the plant and then surfaces all the way up, which you can put into our text view with data binding to surface. So that's Sunflower in a nutshell. Now, this is just scratching the surface of each one of these Jetpack components. And if you'd like to learn more, please go to developer.android.com/jetpack. We have a wealth of resources, talks, blog articles there covering all sorts of Jetpack uses. And if you're interested in learning about Sunflower, it's available on GitHub. So thank you for coming, and I'd love to hear about your experiences in Jetpack, so please find me on the floor and let's chat. Thank you very much.